Sorry. Sorry, I was looking for the old-fashioned microphone, you know, the big one from the 1950s, but not wave my arms around. Welcome to everybody. My name's Stella Bruzzi, and I'm Dean of the Arts and Humanities faculty here at UCL. Welcome to everyone here for this main keynote for the conference on the theme of Worlding the Low Countries, which you've been enjoying today. The conference has been organised by UCL on behalf of the Association for Low Country Studies in the UK and Ireland, and forms part of our great celebrations of the centenary of Dutch studies here at UCL. I'll leave the introduction to our illustrious keynote speaker to my colleague Ben Kaplan from the History Department, but just to say a few more general. Sorry, I started without you, Uli. Oh! I think this is such a fantastic logo. It's really amazing. So that's my own. I thought you'd gone to get your own personal water bottle. I thought, look, you could wait. You know, but no, thank you. That's haven't even sort of done anything to deserve it. But so the centenary celebrations have included a reception yesterday, today's wonderful conference, and an alumni event on Saturday. Please ask UCL colleagues for further details. With regards to the centenary of Dutch Studies at UCL was founded in 1919 in an attempt to improve international relations after the devastation of World War I, which links directly to the topic of the conference, namely the Low Countries and the world's cross-national cultural and cross-national and cultural exchanges. Clearly, sadly, there are also many topical references that can be linked to the theme, not least the idea that we might have learnt from the lessons of history. Just thinking now and heading towards the election of December the 12th. The talk will be followed, tonight's talk will be followed by a reception in the South Cloisters. For those of you who don't know UCL, just simply follow people who do. And conference guests, well, because, one does find lost people. So just look at someone who knows where they're going. Conference guests are invited to a dinner afterwards. I'm sure you've been given details of that, hosted by Flanders House, which is in Cavendish Square. So presumably, again, follow someone who knows where they're going. So it just leaves me to say I wish everybody a wonderful evening. And also, I think it falls to me just to say, in the unlikely event of needing to evacuate the Gustav Tuck, that is, you can go out there, then go down those stairs. I've never known, that should open, but I've never known anything happen through there. So I would rely on that exit, is all I'm saying. And I wish it were warmer, but I think we're relying on body heat and general scholarly excitement to keep us warm. Ben, over to you. And thank you for my bottle.
Hi there, can you hear me? Can you hear me back? Good, okay. I'll skip the microphone. I'm here just to introduce the keynote speaker. It's a great pleasure to introduce to you Dagomar Degroot, who's Canadian but does pronounce his name in the good Dutch manner. His BA and MAs were from McMaster University. He got his PhD in history at York University. What he's going to be speaking about this evening is related to his first very successful book called The Frigid Golden Age, Climate Change, the Little Ice Age, and the Dutch Republic, which is indeed a very provocative and interesting book on the Dutch Republic and was named one of the 10 best books in history by the Financial Times when it came out. Dagomar has a topic that, pardon the pun, is hot these days. So he's in a lot of demand. He appears in the media quite a fair amount and has written for things like the Washington Post and been interviewed for CNN. He has a big web presence as well. He's the founder and director of something called historicalclimatology.com. And likewise founded and directed something called the Climate History Network. His next project, talk about ambition, is entitled Civilization and the Cosmos, an environmental history of humanity's place in the solar system. But indeed, this kind of work raises big questions about great and small time scale and how one relates the two to each other in a meaningful and nuanced fashion. One of the great strengths of his work is that it draws out plausible connections, likely connections, that rates these connections in levels of probability and doesn't oversimplify this issue of relating long-term with the very specific local and short-term, which is, of course, something we all grapple with given current climate change as well. So thank you very much for coming all the way, and we look forward to your talk.
Well, thank you so much. I'm also going to try and yell, but please let me know at the back. Please wave your hand if I'm not yelling quite loudly enough. It's such a thrill and an honor to be here with all of you today and to have my name pronounced right, for I think more times than it's ever been pronounced right since I joined academia. Degroot, I always tell people, but it doesn't really work out that way when they try and say my name. In the next 45 minutes or so, I'm going to try and argue that the history of this little country, right, the Dutch Republic, no more than 2 million people or so, precursor, obviously, as we all know, of the Netherlands, has relevance for the quintessential crisis of the present, which is climate change. And that's often an odd argument to make for many audiences, so bear with me. And it's an argument that's enabled by a true revolution in how we understand the past. It's a revolution powered by the so-called paleosciences, the sciences of the past. Paleoscientists have uncovered evidence in everything from the molecules of our genetic code to the molecules embedded in sediments at the bottom of the ocean or in the blue ice deep under the ice sheets of the Antarctic for dramatic changes not only in the natural world in the past, but also in human beings, and often coupled changes in the natural world and different human societies. Paleoclimatologists find so-called climate proxy sources from natural archives, and these are aspects of the natural world that in some way in their composition register the influence of past climate change. Best way to describe this is through an example. If you drill into an ice sheet, for instance, in the Antarctic, you'll get a long tube that's called an ice core, and that tube will have a series of layers. The layers tell you about annual precipitation at that ice sheet. And the composition of those layers tells you about precipitation, but also about temperature changes, because temperature changes have bearing on how it precipitates at the poles. So the composition of this core tells you how climate has changed in the past. Now, this is a massive project. This map may give you a sense of the magnitude of the paleosciences these days. These are just locations where different proxies, including ice cores, have been exhumed around the world with National Oceanic and Atmospheric Administration funding, or NOAA funding. So you can get a sense here of the magnitude of the effort. And it has yielded so-called reconstructions of past climate change. A reconstruction is just a graph or a map that shows how climate has changed in a particular region. In this case, the entire northern hemisphere between the year 1000 and 2000 CE. I doubt that you can make it out from all the way up there, but this just shows you degrees Celsius from -4 degrees Celsius at the bottom, all the way up through positive 3 degrees Celsius. And you'll see that there are different lines here, blue and orange. That just represents different reconstructions compiled with different proxy evidence. Now, these reconstructions are incredibly important for a host of different reasons. One, they give us a sense of just how dramatically Earth's climate is changing now with reference to the past. They give us an indication of the causes of past and present climate change. And depending on the resolution, they tell us how local or regional environments have changed and may change in response to climate change. But they also have great importance for historians, because they show that the natural world, which is so often represented as a sort of stage for human drama, right, in history books, in fact, the natural world is an actor that has changed dramatically in the ways that intrude on human history. So the first thing I'll say about this is, okay, if you brought this all the way to 2019, right, and you squinted, maybe took a little step back, it would start to look a lot more like a hockey stick, right? Which is to say, this part would be stable, or look stable to you, and the blade would shoot up, right? So we are now at about 1 degree Celsius, almost 1 degree Celsius warmer than the mid-20th century average, which is that baseline right here. Okay, so that's the first thing I'll say. Things are really hot now. But there has been significant variability. I mean, maybe not in this room, but in general. But there has been significant variability in the past as well. In parts of the northern hemisphere, temperatures were warmer during something that used to be called the medieval warm period, but is now more frequently referred to as the medieval climate anomaly. But then also, there's a period of climatic cooling that sets in arguably around the 13th century with the great eruption of the Samanas volcano. That's erratic, right? But generally a good deal colder than what came before or after, and that is called the Little Ice Age. It lasted for about 6 centuries until the midpoint, maybe the later decades of the 19th century. Now, the Little Ice Age is a misnomer, if ever there was one. It's not actually an ice age. Temperatures decline on a decadal scale by about 0.5 degrees Celsius. So by comparison, the great ice ages, we're talking about 4 degrees Celsius worth of cooling. So this is much, much smaller than that. In addition, it's not little, right? It still lasts 6 centuries. And the cooling is not homogeneous or continual. It's erratic. It's frequently interrupted by warmer decades or years. In addition, it's not quite global. So, I'll get to that right now, actually. It's not quite global. So these are rather confusing maps. They're from a new article. And the differences in color in these maps just show you when different regions most experience the cooling or warming of past and present climatic regimes. As you can see, this is the current warm period here. Just about every part of the world now is enduring a record-breaking heat. So that would mean, this is synchronous, this is homogeneous, everything is hot. Not so for the Little Ice Age. Different parts of the world cool at different times. The 17th century, which I try to highlight right here, is the coldest part of the Little Ice Age in Europe, parts of North America, and parts of the Arctic. The 19th century is considerably cooler in other parts of the world. Now, the 17th century is bookended by these two, you might call them very little ice ages, or maybe just cold waves during the Little Ice Age. The so-called Grindelwald fluctuation from the late 16th through the early 17th century, and the Maunder minimum from the late 17th through the early 18th century. And these cold waves of the Little Ice Age are caused largely by volcanic eruptions. You get an explosive volcanic eruption. It releases sulfur dioxide into the stratosphere. Chemical reactions then change that sulfur dioxide into basically dust, and prevailing winds may carry that dust across the northern hemisphere, or if the volcano blows up at the right latitude, across the whole world. It's called a global volcanic dust veil when that happens. Cooling can be acute, but it can also be long-lasting if the cooling triggers so-called feedbacks in the climate system. A lot of those feedbacks are in the Arctic. A lot of them are being triggered right now in the very opposite way as a result of anthropogenic global warming. Now, at the middle, maybe the end of the 19th century, Earth started warming. This is a NASA representation of that warming. And we have all of this information not through proxy sources, but through weather instruments. There's a modest warming trend early in the 20th century, and then a modest cooling in the northern hemisphere midway through the century. But warming has been very rapid, some might say even accelerating, since the 1980s, certainly since 1990, and now we are at about 1 degree Celsius warmer than the 20th century average. Again, compare that to the Little Ice Age of 0.5 degrees Celsius cooler in its coldest stretches. And I was thinking, actually, as I was preparing for this talk, a sobering thought, that when I began to write grant proposals about 11 years ago or so, I could say, well, you know, the cooling of the Little Ice Age is the same in magnitude as warming has been so far. So that's why this work is so important, right? Now I can't say that anymore. Now it's the magnitude of warming is about double. Gives you an indication how fast this is moving. And by the year 2100, we're likely headed for a world that looks a bit like this. Of course, this is not set in stone, and our actions in the next 10 to 15 years have tremendous importance. But likely we are headed to a world that's about 3 degrees Celsius, maybe 4 degrees Celsius warmer than the mid-20th century average. In other words, 2 to 3 degrees Celsius warmer than it is now. Now, as you can see, I showed you that little map earlier that showed you that the warming of the present is quite homogeneous and that every part of the world is getting hotter. But you can see it's not getting hotter at the same rate. Land in general heats more than the waters, and the Arctic in particular is getting much, much hotter as a result of something called Arctic amplification. I mentioned those feedbacks earlier. A feedback in the climate system is when there's a process that amplifies warming, for example, in a way that increases the feedback. It's almost like if you're using a loudspeaker, you might whisper, there's a sound that comes out that goes back through the microphone, increases the volume of what's coming out of the microphone, and then eventually you have a shriek. Right? Very similar, actually, in the climate system. That was perfect timing. I have a newborn at home, actually, and I'm very used to that shriek. But yeah, so in the Arctic, you see temperatures 6, 8, even more degrees Celsius hotter than the 20th century average. And so it's not an exaggeration to say that we're creating a new planet. Right? Earth wasn't good enough for us. We're building a new and frankly less habitable planet, a degraded planet. And so there's a tremendous amount of awareness of this threat in the last few years. It's just really been bewildering for me, actually. Exciting, encouraging, but bewildering because the story has been the same now for a long time, right? And only now is the public discourse finally starting to catch up to what the science is saying. And tremendous amount of interest also in what the human consequences of these changes might be. So we have books like The Uninhabitable Earth, which may be the most widely read book on climate change that's come out recently. And they argue that global warming will severely diminish food supplies, for example, or cause economic collapse, tremendous costs in any case. But the most apocalyptic things that they have to say deal with the relationship between climate change and conflict. You may have already heard things like this before. You may have even read this book. Davis Wallace Wells, the author, argues that a planet 4 degrees Celsius warmer, so what you just saw, would have perhaps twice as many wars as we do today, and likely more. He argues that even if we meet those Paris goals, right, at the Conference of Parties a few years back, the initial goals would limit warming to about 3 degrees Celsius. The idea was to have more and more ambitious goals. Even if we meet that, we'll still have at least 40, perhaps 80% more wars. And he argues that climate change has elevated so-called Africa's risk of conflict by more than 10%. That by 2030, in fact, there will be 400,000 more deaths as a result of conflict, battle-related deaths, in Africa. He claims that the US military is, quote, obsessed with climate change. That's definitely an exaggeration. But he cites an increasing US interest in the Arctic as a potential new theater of conflict. And indeed, recently, just a few months ago, there was an important report by former Department of Defense, this is our military in the United States, officials and intelligence community officials, called The Implications of Climate Change for the US Military. Now, I don't know if you can actually make this out at all, but the argument here is that as the Arctic warms and sea ice retreats, sea routes to Asia that are much quicker than existing sea routes will thaw and now become usable even by ships with relatively thin hulls, the kind of ships that traffic the rest of the world, and that hydrocarbon reserves, roughly 20% of the untapped reserves that exist today, will suddenly become accessible. So that this region is being militarized by Russia and ought to be militarized in a more profound way by the United States and allied countries. So indeed, here there's explicit argument for the Arctic as a likely theater of conflict between Russia and the United States. And so you have these popular articles that have similar headlines to this one. Melting Arctic is going to spark violence, or at the very least, a new Cold War. So one of my arguments today is that almost all of this work is based on historical research. It's not done by historians, but it's based on historical research. So let's focus on the Arctic, or on Africa for a second. This information that David Wallace-Wells gives you is based on a study by Burke et al. And the methodology is to take temperature trends, quantify them by year, and then take wars, quantify the frequency of wars in sub-Saharan Africa, and then find if there are statistically significant correlations over the past century or so. Turns out, according to the co-authors, there are. And this has been criticized from a number of different fronts. The argument, probably that's best, is that there are no historians involved in any of this kind of work, and a historian might have told them that global warming in Africa coincides with the Cold War, decolonization, all kinds of other things that increase the risk of conflict. So, there is work that goes much farther back. And this has been pioneered by geographers at the University of Hong Kong, especially David Zhang. And this is a graph from some of their work. It goes back all the way to the year 0, and they use exactly the same kind of methodology. Temperature trends, in some cases precipitation trends, and then crises, including wars. And here the argument is superficially the opposite. It's that climatic cooling in the past, especially associated with the Little Ice Age, provoked conflict both within China and between China and its nomadic neighbors. But really the argument is actually quite simple. And it's that harvest failures, declining resources really, provoke banditry and ultimately opportunistic raiding by nomadic groups on China's frontier. And that's what causes conflict. So again, resource shortages driven by climate change. Now I find this kind of work to be very problematic. I've written about that in several places, including historicalclimatology.com, again, because there are no historians involved. And so what they'll do, for example, is they'll use these data sets of historical crises, often that were created by historians, and they act as though those data sets are comprehensive, but historians never meant them to be comprehensive, right? So they're creating these correlations based on faulty data. And there's a whole bunch of other problems too, like, for example, quantifying wars. Turns out not that easy to do. But luckily, if you ask me, there have been a series of books, an increasing series of books and articles written by historians using qualitative methodology that end up making similar claims. All of these books written about the Little Ice Age, Many of them deal with conflict. 2 of them deal with the Dutch Republic. That's global crisis and nature's mutiny. And they all argue that in periods of climatic cooling, not only lower temperatures, but also associated precipitation extremes either interrupted or shortened growing seasons, causing harvest failures. When it happened for long enough, starvation, famine followed, migration from stricken regions followed, malnourished bodies were more prone to epidemic diseases, so there were epidemic outbreaks. Desperate people turned to banditry, or at least rebellion. The state responded. Opportunistic states again took advantage of the weaknesses of their neighbors. And ultimately, according to Jeffrey Parker, 1/3 of the world's population died in the 17th century as a result of crises that were either magnified or provoked by climate change. I'm going to argue something rather different and finally actually get to Dutch history. And argue that Dutch history can suggest very different kind of relationships. It can show us, for example, that climate change does not, in fact, simply cause war, which may get us to suspect that the future need not be necessarily a more violent place. But lest that reassure you, well, maybe it should a little bit, it can also show us that there are relationships between climate change and conflict that are almost entirely unexplored by journalists, by policymakers, and even by academics. So I'm going to take you through these relationships in the next 20, 25 minutes or so, through a series of short case studies drawn from some of my recent work. So first, climate change, the causes and causes of conflict. And here I'm going to take us into the Arctic, right, that supposed hotbed of violence in the warmer future. And in particular, to a sprawling archipelago, Svalbard, located halfway between Norway and the North Pole, and then the island of Jan Mayen, much smaller, looks a little bit like New Zealand, but part of the same marine ecosystem. In the early 17th century, about 50,000 bowhead whales would calve off the coast of Jan Mayen. These are massive animals, about 100 tons. So smart, marine biologists even suspect they have culture. So they calve there, and then they slowly make their way east to Svalbard, where they arrive in mid to late spring, just as the sea ice would be retreating from these bays. They would enter the bays of Svalbard, and there they would feed, because Svalbard lies at the intersection of marine currents that churn up nutrients from the ocean floor and provide feeding grounds for plankton. So that's where they would feed, in these bays. And in the early 17th century, English, and then Dutch, French, and Danish whalers learned to hunt whales exactly in these bays, just as actually the price of vegetable oils was increasing in Europe, partly due to declining harvests. And the whale oil that they could get from bowhead blubber could be used for lighting or the manufacture of soap. It was smelly, but it was often cheaper than vegetable oil substitutes. What they would do is they would kill whales in the bays and then set up temporary encampments on the coast. They would cleanse the whales, which is strip away their blubber, row the blubber to those temporary encampments, oil the blubber, load the oil into barrels, and then eventually row the barrels back to their ships, load their ships with the barrels, and then move on to the next whale, build the next temporary encampment, and so on and so forth. And they discovered that they could exploit a quirk in the behavior of bowhead whales. If they attacked whales that belonged to the same pod, about 4 individuals, the members of that pod would scatter, but the rest of the whales in the bay would not. They would carry on feeding unconcerned. So if they were careful, they could kill an awful lot of whales in a small space, wouldn't have to move their encampments that much. However, if hostile whalers also entered the bay and started attacking whales in different pods, far more whales would scatter, and it would be much harder to actually make a profit through whaling. So it was in their interest, they quickly realized, to limit access to the bays for rival or hostile whalers. Now, as a result, conflict repeatedly broke out around Svalbard in the first decade of whaling. So that's the second decade of the 17th century. In 1612, for example. In 1613, look at those fancy crosses that show conflict breaking out in the bays of Svalbard. In 1617, and especially during the so-called Troubles of 1618, conflict repeatedly breaking out here between whalers, sometimes involving bloodshed. Now, at the same time, there are also years of peaceful cooperation, which I've shown here with this symbol because I couldn't find a better one in PowerPoint. So in 1611, there's peaceful cooperation between whalers. And in 1614 and 15, peaceful cooperation. And in 1660. So what's going on here? Why some years is there violence, other years not? Well, this graph is a little confusing, but I want you to pay attention to that purple line here. This is sea ice around Svalbard reconstructed using the reports of contemporary whalers on a very simple ordinal scale. 0 doesn't seem to be that much sea ice. +1, lots of sea ice reported. -1, none reported. So now even fancier symbols show when violence broke out. And you can see every year there's either moderate or very low sea ice, violence breaks out. So that's the correlation, right? Very, very rough correlation. Can we move to causation? Well, I think we can using qualitative means. What seems to have happened is that in years of minimal sea ice, escorting warships, usually English warships, would find rival whalers in these bays. And again, remember, it was in their interest to kick those whalers out of the bays. So they would tell the whalers, get out of Svalbard, go back home. But Svalbard has many, many bays. So the whalers would simply slip into the next bay and continue whaling. When they were found a second time, usually the mariners on the escorting warship would be less prone to simply let them leave. Usually they did. Well, then they often simply just went to another bay. And when they were found a third time, that was it. They were simply attacked. So most of the time when violence breaks out, it's because the whalers have the freedom of movement to move into different bays. And why did they have that? Well, it's because there was minimal sea ice. So the whalers could go into any bay they liked, and so could the whales, of course. But in years of peaceful cooperation, sea ice blocked most of the bays of Svalbard. Now there were just a few bays open, and all the whales would concentrate there. And so the united fleets, the Dutch and the English in particular, would face off at around the same time at the beginning of late spring, the beginning of the whaling season. Then they had a choice. Either we attack each other right here and now, or we find a way to cooperate, to access this resource. And every single time, they chose to cooperate with each other, not necessarily with interloping whalers from England or other European countries. But the Dutch and English at this point were the major players. So here we see a story that looks very different from what we might project for the future. Now there's cooling involved, but really we're talking about a resource, right? Climate change is altering how easy it is to access a resource. It's altering the quantity of a resource as well, the bowhead whales. And as a resource gets more accessible and easier to exploit, we see the agents of otherwise hostile companies and countries working together in new ways, which suggests perhaps that these relationships that are drawn between the increasing accessibility of resources in the Arctic and violence are simplistic at best. Maybe. And here you see a satellite depiction of sea ice, even now in the bays of Svalbard, but there's an awful lot less now than there was in the 17th century. Okay. Now let's move on to some of those other aspects of relationships between climate change and conflict. And here I want to focus on the conduct of conflict. So how conflict actually plays out, how it's fought. And I want to introduce you to something called the North Atlantic Oscillation, which is always kind of daunting to my students, but I think we can explain it in a pretty simple way. It consists of a low-pressure zone near Iceland and a high-pressure zone near the Azores. So the pressure in the atmosphere is either quite low around Iceland and quite high around the Azores. Now, when the difference in pressure between these two regions is relatively small, in other words, when it's not that low around Iceland and not that high around the Azores, we say that the NAO, the North Atlantic Oscillation, is in a negative setting. But when the difference is big, so it's very low pressure, it's very low around Iceland and very high around the Azores, we say the NAO is in a positive setting. Now, when the NAO is in its negative setting, winds that normally travel from the west because of the rotation of the Earth, they tend to meander, and they move towards the south, into the Mediterranean region. These are westerly winds, winds from the west. So there's a lot of westerly winds in southern Europe, but far fewer in northern Europe, and there you can have more easterly winds. When the NAO is in a positive setting, by contrast, those westerlies are sort of funneled through the temperature seesaw or the pressure seesaw into northern Europe. So westerly winds become much more common in northern Europe. Now, using all these proxy sources, you can reconstruct the state of the NAO going hundreds, even thousands of years into the past. And what paleoscientists have determined is that the NAO was in a negative setting during every cold phase of the Little Ice Age. Here's a reconstruction for just the 17th century. You can see the NAO is in a negative setting during the Grindelwald fluctuation. It gets into a positive setting in slightly warmer decades that separate the Grindelwald fluctuation from the Maunder minimum, and then back into that negative setting. Now, these changes obviously happened during an awful lot of conflict. All the Dutch historians here will know that. The Dutch were almost always at war, right, in this century. And I want to draw your attention to the three Anglo-Dutch wars of the 17th century, which I've represented here with, again, fancy graphics. Very fancy graphics. The first Anglo-Dutch wars from 1652 to 54. Temperatures were somewhat warmer in Europe at the time, and the NAO is in a positive setting. Now, as temperatures decline, the Dutch and the English fight again in 1664 to 67. Now the NAO is in a very deeply negative setting. And they fight a third time in 1672 to 74. The NAO is in a modestly negative setting. So what we would expect is that winds from the west are common in the first war and less common in the next two wars. And indeed, when we look at documentary sources written during these wars, everything from ship logbooks to intelligence reports, internal correspondence, you name it, we find that during the major battles of the wars, westerly winds are super common in the first war, but much less common in the second and third wars, where easterly winds become far more abundant. Who cares? Right? Why does any of this stuff matter? Well, in the 17th century, if you're a mariner, and these wars were primarily naval wars, wind not only was your power source, but it also determined how easily and when you could move in different directions. And what you really wanted was something called the weather gauge, which is to be between the source of the wind and your enemies. So, for example, in this painting from the First Anglo-Dutch War, if the wind blows this way, from the left to the right, this English flagship here is on the lee side, which is where you don't want to be. And the Dutch flagship at the center is on the weather side. It has the weather gauge. That's what you want, because it allows you to determine how and when you attack or retreat. It gives you something that's called a tactical initiative in battle. And this was especially important during the Anglo-Dutch Wars, because the English were experimenting with and ultimately refining something called the line of battle. The Dutch then hurried to copy them, which is where Sailing ships would sail by each other in single file, firing broadsides, right? The classic sort of image of naval battle in the age of sail. And for this to work, you had to maintain your distance from the enemy, and you had to smoothly sort of turn around your squadrons once you were done passing the enemy formations. And you did it until the enemy formations broke apart. And for that, it really, really helped to have the weather gauge. Now, in this map, you can see why westerly winds would benefit the English. They are sailing predominantly into battle right, from England. And so if you have the wind going from the west to the east, they would normally have the weather gauge. And here, I don't know if you can make this out. Maybe you can see these circles here. Those are representations of battles. Here you can see major battles during the First Anglo-Dutch War, and the arrows represent the direction of the wind, the thickness of the arrow, the velocity of the wind. And here you can see the English actually win most of the battles during the war, and they always have the weather gauge during the war. They go on to win the war and impose a relatively lenient peace. Second and Third Anglo-Dutch Wars, things change dramatically for a whole host of different reasons. The climate is not the only thing that changes. Naval technology that the Dutch use changes dramatically. The tactics they use change too. They're trying to copy the English in many ways. But the environment changes as well. Now you can see that the wind's overwhelmingly right below from the east. The Dutch almost always have the weather gauge, except for here, right, for the English wind. And the Dutch then end up winning the Second and Third Anglo-Dutch Wars. And these wars, in many respects, especially the Third War, are more important for the Dutch Republic. Because they won the Third War, they were able to even continue surviving as a European great power. Now, these relationships extend well beyond the coast. In 1666, as many of you probably know, a fire breaks out in Pudding Lane. Not far from here, actually. At the same time, easterly winds are affecting naval operations, but they're blowing onto the coast as well. And an easterly wind actually blows the fire along the Thames into downtown London, incinerating much of the city. You can see very similar things happening now, unfortunately, in California. And it's the cost, in part, of repairing the damage of the fire that bankrupts the English war effort in the following year. Allows that breakthrough of the Dutch into the Medway and the capture of English ships and the burning of English ships that year. But the relationships also extend beyond the Anglo-Dutch Wars. In 1688, William III launches a massive invasion of England, right, which is then remembered as the Glorious Revolution. And it's enabled by a so-called Protestant wind. But we now know maybe a better term for that is a little ice age wind, right? An easterly wind, this is a representation of easterly winds in ship logbooks written in that year that show how easterly winds are not super common, but they're an awful lot more common than they are now. It's an easterly wind that pushes them across the channel, but also that keeps the English fleet pinned to the coast, keeps them from intersecting. So over the course of hostilities between the English and the Dutch, the environment changes profoundly in ways to favor the Dutch. And this is something that's almost never written about, including in that report on the U.S. Army, right? We never write about or really think about how the battlefields of the future will change. What tactics will be necessary in these altered battlefields, what tactics will fail. So now, lastly, and very briefly, I want to talk about conflict and vulnerability. The last sort of lesson that is rarely talked about from the Dutch Republic. And here, vulnerability really means how much damage are you taking because of climate change. Now, the Dutch revolt against the Spanish Empire breaks out at almost exactly the same time as the Grindelwald fluctuation. And before long, it's fought through a series of sieges. Right? And that's because of all kinds of changes in European military practice that favor defensive warfare. And they include the adoption of the Italian bastion, which is built with stone in Italy, but built with mud, with earth, in the Low Countries. Star-shaped formation that holds out, absorbs artillery fire from besieging armies. So in order to fight this war, you have to build extensive trenches around the cities that you besiege, and you have to be prepared to stay in the field for months, even years at a time. And it's not just, as we normally think about armies that do this, not just soldiers, but whole campaign communities, thousands of civilians that accompany armies that also have to stay here, besieging cities. Now, in the Low Countries, the Grindelwald fluctuation doesn't just make it colder, but also wetter and stormier. So you have to imagine thousands and thousands of soldiers and civilians enduring sieges for months, for years, in brutally cold and wet weather in trenches, right? And receiving logistics, often through waterways that will be frozen. So it becomes incredibly difficult to maintain these people, and many soldiers, freeze to death through exposure, or through lack of food, or for disease outbreaks in the cold, wet conditions of trenches. So it's violence that exposes them to some of the most dangerous weather of the Little Ice Age. And that's true also for this uniquely Dutch practice of military inundation. Right? This is where you would open the sluices of the Low Countries and let in water to literally wash away besieging armies. This tactic was much more effective. You have to imagine if it's wetter and stormier than it was before. For example, during the siege of Leiden, the opening of sluices and the inundation of besieging Spanish soldiers was enhanced by a storm that made the floodwaters come on more quickly. You can see the Spanish leaving the siege of Leiden. But this was also a tactic that was devastating to Dutch farmers, right? You would fill Dutch farmland with salt water that would leave it very difficult to use for years on end, gutting agricultural productivity in the Low Countries, ruining the lives and livelihoods of farmers on a large scale. So again, it's violence that makes people much more vulnerable to a changing climate and ruins people's lives and livelihoods. And I want to return to the Arctic then to give one final example of this. After that first decade of the whaling industry in the Arctic, the English decided to set up permanent encampments in the south of Svalbard. And the Dutch set up just one in so-called Amsterdam Island, Smerenburg, right? Blubbertown. And this became a fairly large settlement in the summer during the first half of the 17th century. The new system worked well, as you can see, to separate the Dutch from the English. And so there were fewer hostilities between the English and the Dutch. Yet it did have one glaring weakness, which is that if there wasn't that much sea ice, then before the whaling fleet arrived in the spring and after it left in the fall, these permanent encampments were abandoned. They had a lot of valuable commodities and equipment, so interloping whalers, pirates, I guess you could say, could easily raid the permanent encampments and steal a whole bunch of stuff. And because of this threat of violence, really, the English and then the Dutch tried to recruit volunteers to stay in the Arctic year-round, essentially colonize the Arctic. The English Muscovy Company, for example, tries to hire Laplanders with the assumption that the Laplanders will be able to endure the cold. That fails. And in desperation, they even try to recruit condemned criminals with the promise that they will not only get out of execution, but they will even get some riches if they stay in the Arctic. And even that fails. But the Dutch have a little bit more success. Actually, an English crew is accidentally marooned in Spitsbergen and manages to survive. And that inspires some Dutch volunteers to sign up. And their overwintering attempts fancifully look like this in Svalbard and Jan Mayen. One crew actually manages to survive. All the rest die before the spring arrival of the whaling fleet. And in fact, they have the misfortune of making this overwintering attempt at probably the worst time in the 17th century to do it. It was the tail end of the Grindelwald fluctuation. In green, you can see Arctic, hopefully, you can see Arctic temperatures exceptionally low, maybe the coldest in 200 years. In blue, you can see sea ice in the western Nordic Sea. Not that much sea ice, but in red, you can see the NAO, which was positive. In the Arctic, when that happens, sea ice is pushed into the bays of Svalbard. So it was exceptionally cold and very icy. That made it very hard to forage for the kind of stuff, the weeds, that would hold off scurvy. So all of these whalers succumbed to scurvy, except for one fortunate crew in Smerenberg. So again, you have the threat of violence in this case, exposing people to the very worst weather of a little ice age. And who's exposed? It's certainly not the directors of the Dutch Northern Company, the whaling company, for example. It is people at the bottom of the social pyramid. Right? So that suggests to us that for the world to be more resilient in the face of climate change, it should also be a more peaceful place. Luckily, we now know that that's possible. Or we hope, at least. So just some parting thoughts then. I want to really emphasize that historians, maybe especially Dutch historians, have stories to tell that matter today in part because so many of our projections of future climate change are based on ahistorical misreadings of the past. And those stories, I think, are beginning to sketch a picture in which the relationship between climate change and conflict is a good deal more complex than commonly assumed. So if you find this kind of stuff interesting, you can read more about it in the Frigid Golden Age, I can promote this book, or at historicalclimatology.com. Thank you so much. Is it time?
Yeah, I think so. Thank you very much, Dagomar, for that fascinating account and the correlations that you draw in a nuanced way between conflict and climate change, rays of hope for the present and the future, and the Dutch not necessarily suffering from bad weather, not finding ways to take advantage of it, finding silver linings to things which cause potential difficulty. So we do have time for some questions.
If there are any, of course.
Thank you so much for that. So this is a question which comes out of research one of our PhD students is doing, which is about the revolts in Andalusia in the middle of the 17th century that Jeffrey Parker talks about in the Global Climate book. So he has looked at market integration, and to what extent market integration can offset adverse climatic events in particular places, if you can buy supplement from elsewhere. So I just wondered, in your work, how does, do you have any theories or overarching ideas around the possibilities that market integration offers?
Well, absolutely, yeah. So I have a chapter that deals partly with that in the book. And I do think there's something to that, right? Because the Dutch diet, first of all, was quite different from the diet of many surrounding communities and societies. And also, of course, a lot of food in the Dutch Republic was imported. And then, in many cases, also exported, right? And so the exports of food allowed the Dutch merchants to exploit food shortages elsewhere. The imports of food potentially add a certain kind of resilience to the Dutch diet. And some other things do too. Jessica Dijkman, for example, has written about the role of urban charities in minimizing food shortages in the Dutch Republic. So I think that's very important. At the same time, there's some additional complexity here because in very cold weather, some of those ports could be frozen, right? Some of the waterways that use to transport food could be frozen as well. And so then there are food prices soaring even in port cities in the Dutch Republic. So it's complex, and that's kind of the story of the book as well. This is maybe not the most exciting message. On the whole, I argue that the Dutch benefit probably more than they suffer, but there is both suffering and exploitation benefits in just about every chapter of the book. So it's complex, but I think your student is definitely onto something.
I found this a very interesting talk, and I was wondering why we, as 21st century people, we have a very good view on the developments of climate over the past centuries. I was wondering, during your talk, did those people of the 17th century know about anything like little ice age? Did they know about, they were really experiencing a relatively cold period? I mean, were they told by their grandparents or family stories that in the old days temperatures were way more up than that?
So I think there's part of the book, I can't remember now actually, that deals with that as well. There's certainly part that I wanted to add to the book that does. So they had no, as far as I can tell of course, they had no understanding of changes in average weather, because you need statistics for that, and statistical work was just then sort of developing in the 17th century, But that's not to say they had no understanding of changes in meteorological extremes. They did seem to have that actually, sometimes because they consulted textual evidence for past weather, sometimes because they consulted landmarks that, for example, marked when water reached a certain height, sometimes because they consulted memories. And what I found in my research is that those memories were accurate on a generational sort of scale. So you could go back a generation, maybe two. You know, if someone says this is the coldest winter ever, they were right for about 2 generations. Then that sort of broke down. Right? So there was an understanding of changes in weather extremes. There was also an understanding of the need to be able to predict changes and early attempts to kind of quantify those changes, but not what we would call climate science now. And there was certainly no modern understanding of the causation of climate change. So actually, I've been looking for stuff like, did Dutch naval officials realize that wind patterns were changing and then try and exploit it? But I've never been able to find anything like that, unfortunately. Yeah. Yes, absolutely. So I mentioned causation, right? Why is this happening? There was debate about that in the 16th century. What is causing this? Is it God? Is it the devil? Or is it entirely natural? Right? And is this also leading to, some sort of apocalypse? I haven't dealt with that as much in my work, but other people are beginning to explore what this kind of weather meant for individuals at the time. And as far as I understand it, the idea that there were more natural explanations that sort of took root over the 16th and the 17th century is simplistic. That in fact what you can see is a whole bunch of competing ideas about the causes and the significance for these events that kind of percolate at the same time.
I was very interested by the remark you made about climatic tactics. And I was wondering, how do you address in your research the difference between, let's say, the active influence of climate on a society at a certain moment, and say, well, that's somewhere or another it means a certain degree of passivity. You can't do anything about it. And on the other hand, you've got these climatic tactics, flooding territories and this sort of things. Does it mean that we have to try to address these two different processes of dynamics in a different way, or not? How do you look at that in your research?
Now that's really interesting. So there's an active sort of element of the response, but there's a passive element in terms of the climate just happening to people, right? And I think it's useful to distinguish between climate and weather as well, which is kind of an obsession of mine in the book, where I look at the relationship between enough weather events and human events and then build up an overall story of the relationship between climate change and the broad sort of sweep of human history. In this sense, the past may have been fundamentally different than the present, where we are both causing and responding to climate change, right? All the agency in the past is on the response, although that has been disputed recently as well. And I'm hoping sort of dancing around your question a little bit, but it does maybe get us to think about human agency in different ways, right? Because on the one hand, this history is being affected by non-human forces. On the other, there are these responses. I think I'm dancing around your question a little bit.
Well, I'm glad to hear that it's not only thinking about how do we have to do this, how does it relate to flooding and getting a tsunami opening. It's some sort of different strategies or dynamics or what to do with it, how to analyze it.
I think in environmental history, so that's, I'm an environmental historian, we look at the mutual interactions between environment and nature. In that kind of history, we always kind of deal with these different kinds of agencies or actancies, right? Where the natural world has this kind of agency in our affairs that has often been overlooked in history. But then what tends to happen among some geographers and frankly some environmental historians is that human beings in these narratives lose all their agency and they become passive victims. So I showed you a lot of that other sort of scholarship, right? And my criticism of that scholarship, even the qualitative stuff, is that too often human beings are reduced to just sort of being passive in the face of these great forces. And that's not how I see it at all. When we zoom in, especially on the local level, and I think that is important, if we really get to these spatial, temporally small stories and build them up into bigger stories that way, then we can find much more agency, people struggling to interpret, but also dealing often constructively, ingeniously, with changes in the natural world. And it's those stories where there's agency on both the natural and the human scales and systems that I like to tell. And I think are often overlooked when we look at the past and when we project the future.
I think we perhaps have time for just one more question.
Well, you organized that first, like to say that we're very happy that we invited you.
Thank you so much.
And secondly, I also want to maybe go back a bit more specifically to the conference topic, like world in the low context. So I was wondering if you could say a bit more about how global this history is, and in what way it can translate to the present. It feels like we've now focused mostly on the conflict between the Dutch Republic and England, which are at this time of both kinds of major forces. One of the difficulties today, of course, is that we are looking at a global scale in which the forces and the equality of the distribution in political military power, of course, very in disbalance. So I was wondering if you could say something more about that. Or if it's, it's a very broad question, but I mean, that will get along to the exception.
So the one thing I really want to emphasize before I forget is that this story is not complete. This is, I hope, not the last work written about climate change in Dutch history. I want to help to start a conversation, but there are an awful lot of topics that I didn't get to in the book. For different reasons, either the climate reconstructions were not at the time good enough, though they've improved dramatically, or I just ran out of time and space. So in terms of how global this story can be, it can be a lot more global than what I've described now. And the book is a lot more global in that it looks at journeys across the world, for example, how Dutch East India Company voyages were accelerated by climate change, for example. But it doesn't step away from the metropole as much as it could. And there are now scholars who are starting to do that. For example, Nicholas Fuengen, looking at Brazil and conflict and climate change. But there's an awful lot of space for more research. So I want to emphasize that. I also would say that these histories are inherently global because you're looking at global processes that are triggering many of them, right? So the Little Ice Age is something global. You're connecting volcanic eruptions in the tropics to conflict in the North Sea. Right? So inherently, these are global stories. And if they have any sort of significance at all for us now, that significance would be global as well, right? Because every part of the world is suffering from climate change, and conflict these days is global. Now, how much relevance this work has for the future is also an open story, I would say. I like to say that the past can give us parables. You know, it doesn't tell us exactly what's going to happen, but it gives us parables that hint at sort of deep truths, or that open our eyes to different kinds of relationships than we have been aware of before. But that's about it. Other people may differ, but that's also kind of a... these parables have general applicability, and therefore they are also of global significance, I hope. So I hope that touches on some parts of your question. There was one other aspect that was interesting about the nature of conflict today, but maybe we can talk about that in person.
Yes, perhaps it's time to move on, but not before thanking you very much for a fascinating and